Okay, so it looks like it is. I understand it is kind of annoying when they just do the integral without actually showing you how they did it. So how did they do this right here? Anybody know? How did they get that? There's an identity that's true, but if you don't have an identity, and let's just say I gave this to you right here on a test, what would you do? You need to use U substitution. Yeah. What's interesting is just because there's only an equal sign doesn't mean there could be some serious work. Answer booklets are inconsistent that way. Sometimes they show you more than you need, and sometimes they don't show you enough. I think I told you what's my least favorite word in all of mathematics. Clearly, is an awful word, right? Because either you know it or the book just insulted you a little bit, right? Okay, so in this one, if we use U substitute, I like doing that extra step. I like doing that. I like doing the little isolation there. So now when we do this, we get the integral of t times u, but instead of dt, what do I write? What? T du, like this? Dt is t du, right? Okay. So we now have the integral of t squared u du, right? What's one challenge at this point? What's one problem or one stopping point for us? ln of t for u. So then we get t squared equals ln t du. Okay, now what? Are we at a happy place right now or a sad place? We're a little sad right now because you've done everything correct, but you've come into a dead end. And so if we're going to use parts in this, which might make sense because this chapter we just did parts. I mean, I'm not saying that ironic. I'm saying it might. They tend to heavily weight the types of methods you need to use based on what you just covered. So if we do that, u and v prime. Okay, so what do we think u is going to be? ln of t. Might be nice. What's u prime going to be? 1 over t dt. So if u is ln t, what's v prime going to be? T dt. So what's v going to be? 1/2 t squared. So if we write this out, we now know it's going to be u times v. So what is that? 1/2 t squared ln t. Is that correct? Minus the integral of what? Is it u prime v? Yeah, it's u prime v. Is it uv prime or?
No, it's
It's u prime v, right? Is it u prime v? Help me out here. It's really easy to confuse me on this stuff. Thank you. So we end up with 1 over t dt. That's u prime, and what's v? 1/2 t squared. Oh, the dt is already there. Now, what's the nice thing that happens at this point? The t's cancel. That's right, and you're left with minus 1/2 of what? T dt. Now, is that something that makes you happy? Yeah, in terms of the 1/2 of. So what's the integral? What's the integral of t? 1/2 t squared. Is that correct? Does that look right? Now the question is, yeah. So look, no, you're absolutely right. So I think we've done everything correct. This 1/2 gets pumped out there because we're integrating t to begin with, right? And then you integrate again, and you get. So you think it's this 1/2 what t squared ln t minus 1/4 t squared plus c, right? I think you're right. I think there is an answer. So Lauren, do you see what the answer he has up there? What does it look like it's missing right here? It looks like there's a 1/2 missing right there. Yeah. Cool. You found an error. I agree with you. Unless, I mean, let's just, who's seen something like that before? Yeah, maybe a little bit, right? What's one nice thing about that one? Can someone tell me one nice thing about that one? Factor for us. Is that kind of nice? Sure. It is kind of nice. The challenge is now, we don't really have a way of just looking at that and coming up with the integral. It's not like we're undoing some known derivative. Does anybody know what this topic is, what we have to do to this? Yeah, PFDs, not the personal flotation device, but partial fraction decomposition. So what's our first goal? Our first goal is to rewrite this into smaller pieces, and each of those pieces is really, really nicely integrable. So what are we answering? We're answering this question right here. We need to find out what this equals in terms of a over x minus 2 plus b over x minus 5. That's what we're trying to figure out. A and b are what? They're constants. They're constants. What should we do if we wanted to solve? I mean, it might seem like it's a futile effort because we have one equation and lots of variables. It actually works out pretty nicely. What can we do to this to make it a little bit more easy to digest? Yeah. Multiply everything, right? If I do that, which is a great move, hit it with 1 equals a times x minus 5 plus b times what? And you get to here, and there are two different paths for this. There's the path where all the logic, at least in my head, makes sense and takes a little while. Let's do that way and see how long it takes. This one's relatively straightforward. If I were to multiply this out, you end up with ax minus 5a plus bx minus what? 2b. So we have 1 is equal to, we have a plus b times x minus 5a minus 2b. I'm just rewriting this to show you what I mean by the logic. Plus negative 5a minus 2b. Did I do my algebra okay, right? Did I regroup things okay? I think I did. How many x's are there? There's a plus b x's. So at this point, can you tell me one thing you notice? What does a plus b have to equal? At this point, you know that a plus b must equal 0. That is true. Absolutely. What about negative 5a minus 2b? That has to be 1. So now how many equations do we have? We have one equation and two equations. So we have a is equal to negative b. We plug it in. We get negative 5 times negative b minus 2b is equal to 1. So what do we get there? 3b. Is that right? Equals 1. So what does b equal? 1/3. So that means that a is equal to negative 1/3. So if we used all that logic right there, we now can write this as negative 1/3 over x minus 2 plus b, which is 1/3 over what? X minus 5. At this point, is that something you guys are pretty comfortable integrating? Get some natural logs in there, take the fractions up front. That's nice. Now, here's the challenge is, not the challenge, but is there a faster way? And Nate, you used this before, right?
Yeah, you just plug in one of the opposite sides.
Yeah, so here's the thing. There's this, years ago, the term I came up with, I called them like magic numbers. Magic numbers are numbers that I think really, really help you. So these statements, the logic I always had in my head, and there's a flaw in this logic, which you'll see in a second, for these magic numbers, you're applying the magic numbers to the original line that you have right here. What number could I plug in there that's really helpful? Like x is equal to 5. That statement needs to be true for all x values, or as far as I understand it, it needs to be true for all x values. If you plug in x equals 5, what do you end up with, Matt? 1 is equal to b times 5 minus 2. So 1 is equal to 3b. b is equal to 1/3. What's the other magic number you could plug in? You could plug in 2. So you end up with 1 is equal to a times 2 minus 5, and then the other one goes away because it's 2 minus 2. Is that correct? So we have 1 is equal to negative 3a. So what does a equal? Did we get the same answer? The challenge, and this is a small challenge, and you can definitely use this. I am okay with you using these magic numbers. It's totally fine with me. The logical inconsistency I have in my head right now, and you're welcome to try to figure it out. I would really like to know why this still works. Look at the original integral. What's the original integral? Integral of 1 over x minus 2 times x minus 5. What's the domain of that function? Anything but 2 or 5, right? So there's a little bit of an inconsistency here that I haven't quite rationalized in my head. That being said, I have done this kind of math right here many times in my life. And does it work every single time so far? Yes. I have yet to find a counterexample why this doesn't work sometimes. The reason this magic number stuff is so helpful, this is a really relatively basic example. Can the partial fraction decomposition get much worse? Seriously, not much. Can it get much more complicated? Yeah. And would you want to use the full logic way to do those for the complicated ones? Just say no. Just say no. You really wouldn't want to. Because you end up with like 3 simultaneous equations and then 4 simultaneous equations, and then you make one typo, and then all of a sudden instead of 130 you get 15, and then your answer makes no sense, and you're sad. If you want to come up, if you can come up with a reason why this works, that would be great. That would be great. Here's the other thing that's really nice. I verified this. I kind of remembered it, but I verified it. On the AP Calculus DC exam, for partial fraction decompositions, you only have single power non-repeating terms. Look at the denominators up there. What are the denominators? X minus 2 and x minus 2 and x minus 5. Exactly. X minus 2 and x minus 5. They are linear and they're not repeated, meaning they're not squared. Does the game change a little bit if they're squared, or if you have like 2x plus 3 on the bottom, or 2x squared plus 9? Yeah, the game changes a little bit. The algebra just gets more complicated. This is a good choice on their part, because if you have higher than single power repeating terms, if that's fair game, do you know how much algebra you end up having to do? Too much. It's too algebraic reliant. The AP Calculus test is on what? AP Calculus. Does that mean you totally don't see any trig? No, you see trig, right? Do you see other forms of math? Absolutely. But a good decision was made, like, that would be too much. That would be too much. That being said, will you get some homework problems where you need to find a slightly higher order PFDs? Yeah, a little bit higher. Break down into? What would be the 2 integrals that you need to do? Umi, what's one of them? 2 over x? Anybody have the other one? Who agrees with those two right there? Who agrees? Only one person's in agreement? 2? 2? So you have x plus 2. Look, okay, so we definitely need to do this. Okay. So this is x plus 2 over x times x plus 1. So you're looking to break it into a over x plus b over x plus 1. Is that correct? So what do we multiply both sides by? Times x plus 1. So you end up with x plus 2 is equal to a times x plus 1 plus b times what? What's one great magic number, Matt? Negative 1. If x is equal to negative 1, what do you end up with? 1 equals b times negative 1. So b is equal to negative 1. What's another great magic value? 0. So you end up with 2 is equal to a times 1. So a is equal to, what's a equal to? 2. So, nice. So did this work out? Did you get it right? Nice. Now can you integrate these? I hope so. I hope so. Can someone tell me what what's the answer to this going to be? 2 ln of what? You say x or the absolute value of x? What do you think is it going to be this? Do I need the absolute value? Yeah, we don't have limits of integration, so we need to do it. Minus what? ln of what? Absolute value of x plus 1, yep. Plus what? All done. And you need to say in your head, that looks like something. That looks like something. Because if you recognize it as something that looks like something, then you can get an idea of what to substitute. It's a paradox. Like, if you know what the goal is, you should be done, but not really. You need to know how to get to the goal. Does anybody know what that kind of looks like? Maybe arc sine, or so sine maybe in there somewhere. So let's just pull something out of thin air. Let's let x equal sine theta. Does that sound like a good idea? Yeah, sure. So literally we're just doing u substitution, but we're going to use a trig identity after we do the substitution. So if x is equal to sine theta, what does dx equal? Cosine theta what? D theta. Nice. So if we plug this in, if we do the substitution, we end up with the integral of 1 over 1 minus x squared. So that's sine squared theta, like this, right? But instead of dx, what do I write? Cosine theta d theta. Because dx is what? Cosine theta d theta. But now what do you see? Yeah, you should remember cosine squared plus sine squared is equal to 1. So what does cosine squared equal? I'm using shorthand, of course, right there. So what does this turn into? The square root of cosine squared theta cosine theta d theta. Well, what's the square root of cosine squared? So you end up with the integral of cosine theta over cosine theta d theta, which is equal to what? 1 d theta, yeah, not theta, so it's just d theta. So what's the integral of that? Theta plus what? C. Well, we're not done yet because we'd like to go back into x. If x is equal to sine theta, what does theta equal? Yep, inverse sine of x. So we take that, we plug it in down there, and what do we end up with? Yeah, inverse sine of x plus what? C. So when you look at this, you might realize, oh, this is inverse sine. This is the derivative of inverse sine. So if you take the integral of this, you should get back to, what should you get back to? Inverse sine. Great, very nice. Does this work out about as cleanly as it possibly can? Yeah, this is about as clean as it possibly can get. Is this almost the same thing? This is similar to what we did. We did one like this before. It's very similar. What number there is the one number that kind of annoys us a little bit? 4. Without doing any manipulation to this, does anybody want to choose something to substitute in for x? Anybody want to guess what we can substitute in for x? I'll give you a hint. It's going to be trig. Yeah. It's going to be a trig function. Oh, what did you want to substitute in? Okay. So you could substitute in x over 2, and like basically you want to factor out the 4 first, right? So what Umi is saying she wants to turn this into the integral of 1 over 2 times the square root of 1 minus x over, 2. You want to do that, right? You absolutely can do that. That's totally fine. That's totally fine. Let me show you a way that makes it a little easier to write at least, and take whatever you can get. Instead, let's let x equal 2 sine theta. If we let x equal 2 sine theta, what happens to the integral? 1 over 4 minus 4 sine squared theta, like this. And instead of d theta, instead of dx, what do I write? Times what? What does dx equal? 2 cosine theta d theta. So this is, hold on, just let me do it and then you can ask. The reason I like this is it's a little easier to now what can I pull out? Now what can I factor out of the, oh, you see 4s in both places. You see a 4 in both places. Does it change the overall work? Not really, it doesn't. I just like writing that as opposed to a fraction inside the radical. That's the only literal difference, really, truly. So in this case, let's finish it here. What happens here? You end up with the integral of 2 cosine theta all over 2 square roots of 1 minus sine squared theta d theta. What cancels here? Yeah, this cancels, right? But what's 1 minus sine squared? Cosine squared. So what happens? So you have 1 over what? I'll pause it here. What have we not substituted back in? So this is theta plus c, but go back over here. Do you see this one right here? What does that mean sine of theta is equal to? X over 2. You have to divide by 2 first, right? So what does theta equal? Sine inverse of x over 2. So you end up with sine inverse of x over 2 plus c. Now is that slightly different than what we had before? A little bit. You end up in the same place. You can do either path. So Umi, if you want to take the 4 out first, totally fine. Absolutely totally fine. What are the x-intercepts? No. The x-intercepts are what? You can do it in your head. 3 over 2 and negative 3 over 2. I know, it hurts, I know. What are the y-intercepts? Negative 3 and 3. Very good. So then what do you do with those 4 points? You connect them. So we have a nice ellipse. So if we want to find the area of that ellipse, we need to set up an integral. Do you notice any symmetry in that shape? There should be some. It's symmetric over the and symmetric over the y-axis. So when we do this integral right here, we need a function, right? And we also need the limits of integration. What might we need to isolate in order to find the function? Our function, so can someone tell me you got y squared is equal to 9 minus what? So what does y equal? Well, plus or minus this thing, right? Because it's not a function. So if we're going to integrate this thing, can someone, anybody want to guess what we're going to set up for the integral? I'll give you a hint. We're going to put this in here. What are the limits of integration going to be? Negative 3 over 2 to what? 3 over 2. So we're scanning from here to here. But then that would just give us this, right? So what do you have to do? Times 2. We can make it a little bit easier for ourselves, though. So we double this thing. Is everybody with me so far? We double this thing. We put some symmetry here. So what could we do instead? No, don't isolate x. Umi. So what'd you say?
4 times this one.
Yeah, so 4 times, and then what do you make the limits? Again, it's an x, so you have to choose x values. So what's it going to go from? 0 to 3 over 2, exactly. So the easiest way you can set this up is the following. The easiest way you can set this up is the following. Take a look at this and make sure you understand what we did right there. Have any?